To Algebra 2, Lesson 4-4, Adding and Subtracting Rational Expressions. In this lesson, we'll be able to find the sum or difference of rational expressions. The vocabulary we're going to use in this lesson would be compound fraction. So let's start with critique and explain. Theo and Shannon find the following exercise in their homework. 1/2 plus 1/3 plus 1/9. Theo claims that a common denominator of the sum is 2 plus 3 plus 9, which is 14. Shannon claims that it is 2 times 9 times 9, 2 times 3 times 9, which is 54. Who's correct? Explain why not. This is like basic math, right? Are they both correct, or is Theo correct or Shannon correct? Shannon, right? Obviously, because a common denominator means you need to multiply the denominators in order to make a common denominator that has the same fractions, that has the same factors as the one we originally have. If we add them, there's no way we can rewrite these fractions into equivalent fractions, right? And it doesn't work that way. So you have to find the common denominator by multiplying them. So yes, only Shannon is correct. A common denominator will have each other denominator as a factor. Yeah, and then part B, find the sum. Explaining the method you use. So we want to multiply the denominators out, right? And then make it into 54 like Shannon did. And so in order to make the same denominator 54, in order to become 54, what do you have to multiply 2 by? Or if you divide 54 by 2, what is the other factor? 27. So you multiply 27 to 2 to get to 54. That means you have to do the same thing in the numerator to make the fraction the same. So you have 27 over 54 plus, in the same way, 54 divided by 3 will give you the factor that's been multiplied, 18 over 54. And then 9 times 6 is 54. And so 27 plus 18 plus 6 all over 54 would be equivalent. So that's 7. That's what? 27 plus 18 plus 6 would be 51 over 54. And then can you divide them? Can you simplify them? Yeah, you can. You can simplify by dividing both of them by 3. So 51, you factor it out by 3, you get 17. Divide 54 by 3, you get 18. So this is the simplified fraction. So the sum would be 17 over 18, simplified. So explain the method you use. Convert each fraction to a fraction with denominator 54, and then you add them, and then you simplify. Or greatest common factor would be actually 18. So you can actually, I don't know why Shannon just, well, if you just multiply all of them, you'll get the common denominator, but GCF for all of them would be 18. So in order to make it simple, you can just make it into denominator 18 and then deal with a smaller number. Then you'll just get the simplified fraction right away, right? Let's look at the last part. Timothy states that the quickest way to find the sum of any two fractions with unlike denominators is to multiply their denominators to find a common denominator and then rewrite each fraction with that denominator. Do you agree? The quickest way is to multiply all their denominators like Shannon did, right? Is that the quickest way? Just like we just talked about, no, you have to find the greatest common factor. No, wait, not greatest common factor. LCM, least common denominator. Yeah, because you're finding the multiples of them, not the greatest common factor. So no, it may be faster. If you just multiply all of them, it may be the LCM, but it may not be, like in this case. So you want to find LCM, right? So no, it may be faster to find the least common denominator to solve it. Okay, so why are we exploring this that we have learned years ago in elementary school, right? Because this principle is the same as adding and subtracting rational expressions. Because we're dealing with fractions, we still have to remember all the rules that we have for adding and subtracting fractions, because rational expressions will involve fractions, and it's just that we have polynomials, and we already know how to add and subtract polynomials, so it shouldn't be that challenging to understand this lesson. But let's move on. So in this lesson, we're going to think about this big question: how do you rewrite rational expressions to find sums and differences? Let's start with example 1. Add rational expressions with like denominators. Okay, what is the sum here? Can you figure out the sum when we have rational expressions like these? X over x plus 4 plus 5 over x plus 4. Yes, you have a common denominator, and so you can just add x plus 5, but they're not like terms, so you'll just have x plus 5 over x plus 4, right? So that's it. Part B, you may have different denominator, but if you multiply them out, they might be the same thing, right? So if you distribute this denominator in your second term, x squared plus 3x is the same as the denominator we have in the first term. So just check if they have the same form, and then you'll be able to see easily if they have this common denominator, and then you can just add them. You have like terms, so you're going to add the like terms together. 2 plus 3x would be 5x, and then 1 minus 8 is just -3, -7. So if you add them and simplify, you'll be able to get the final answer: 5x minus 7 over x squared plus 3x. Not too hard, right? So let's look at try number 1, A and B. Pause the video, see if you can do it by yourself. Come back when you're ready for answers. Okay, are you ready? Let's look at part A. You have common denominators, so you would just have to add the numerators, right? So 10x and minus 4x would be like terms. So 10x minus 4x minus 5 plus 8 all over 2x plus 3. Make sure you simplify, would be 6x plus 3 over 2x plus 3. And if you want to factor that out, you can factor the greatest common factor out and write 2x plus 1 over 2x plus 3. But they're both simplified. It just depends if you want to factor out and simplify, and if you want to multiply out and simplify. So you can just leave it like this. Part B, They have the same denominator again, so you don't have to match any denominators. Just add the like terms. You should be able to get 4x minus 26 all over x plus 5. Check your answers if you made any silly mistakes. If you got everything correct, great job. Pat on the back. Let's look at example 2. Identify a least common multiple of polynomials. Now, what if you don't have common denominators? You want to find the least common multiple, right? So first of all, without worrying about the whole rational expression, let's just look at the polynomial and practice finding the least common multiple of polynomials. So part A, if we have these two polynomials, how can we find the LCM? What is the LCM? It is the multiple, but it is the smallest multiple that they have in common, right? So for example, you have 2 and 4, and then you multiply 2 out, 2, 4, 6, 8, 4 out, 4, 8, 10, no, 12, and then your least common multiple would be 4, right? Just like that, we have to factor out our polynomial, and then you can see if there's any common factors there. That is your greatest common factor, but you have to multiply that factor and the other factors at least once or twice, depending on how many times you have the factor out. So this is the method that you use for big numbers, right? For example, you have 12 and let's say 8, okay? So these are bigger numbers. I didn't choose an extreme example, but in order to figure this out, you can first factor them out. I know we're trying to get the multiples, but first factor 12 out. You have 2 times 6, right? And then factor 6 out, 2 times 3. 8 is 2 times 2 times 2, right? So the LCM is the common factors, but if you have repeating factors, you also have to multiply them, and then you have to multiply 3. So LCM is 2 times 2 times 3, which is 12. No, you have to multiply 2 as well, because you need to multiply the times the number that is multiplied the most time. So 2 times 2 times 2 times 3 would be 24, right? So the LCM would be 24 for both of them. It's the least common multiple for between these two numbers. So in the same way, you're going to do the same thing for polynomials. You're going to factor them out first, but they have a repeating one, so you don't have to multiply this twice. But if you have a repeating common denominators, then you just have to multiply them with the most amount of time you see it for each term. So you're not multiplying the total numbers. So here I didn't multiply 2, 1, 2, 3, 4, 5 times, right? You're not finding the total number of the repeated number. You're just finding the greatest number of times it is multiplied, okay, the greatest power of that base. So in this case, you're going to multiply x plus 2 twice, and then x plus 3, right? Yeah, so x plus 2, x plus 2, x plus 3 is x plus 2 squared times x plus 3, and that's your LCM for these two polynomials. Let's look at part B. We have x cubed minus 9x and x squared minus 2x minus 15, and we have x squared minus 5x. We have 3 different terms. So it's still the same thing. You factor each polynomial. You have x plus 3, x minus 3, x plus 3, x minus 5, and then x times x minus 5. So look at the bases. We have x, just multiply it once. and then x plus 3, which is multiplied once, which is the most, and then x minus 5, which is multiplied once at most, and then x minus 3. So you just have to multiply all of the 4 different factors one by one. So x times x plus 3 times x minus 3 times x minus 5. That is your LCM. And you can just leave it as a factored form unless you have to multiply them out. Okay, so let's look at try number 2, A and B. Pause the video, see if you can do it by yourself. Come back when you're ready for answers. Okay, are you ready? Let's check. Try number 2A, x cubed plus 9x squared plus 27x plus 27. You want to factor that out. You might try factoring by grouping first, but then you'll notice that, oh, this is 27 times x plus 1. If you factor this out, you have x squared times x plus 9, and you can't really do anything else, right? So then you have to look at the factors of 27 over 1. And so plus or minus 1, 3, 9, and 27. You'll see that if you divide by -3, you'll see that you'll have a remainder of 0. So let's check. So you put down 1, multiply, -3, and then you add, multiply, and then you add, multiply, wait, no. Yeah, and then you add, and then you have a remainder of 0. So you know that x plus 3 is one of your factors. So factor it out. You have x plus 3 times x squared plus 6x plus 9. And then you can factor the second polynomial out again. You have x plus 3 squared. And so you have really x plus 3 cubed for this polynomial. And then if you factor this out, you have x minus 7 times x plus 3. And we have a common factor, but x plus 3 is repeated 3 times, so you want to multiply x plus 3 times, so cube, times your other factor, x minus 7. So that's part A. Let's look at part B. We have 3 different factors. Yeah. And then, so you want to factor them out first. You can factor out 10. You have x squared minus y squared. And then you have 15. You can factor out 15. So you have x squared minus 2xy plus y squared. And so there's no other factors that you can factor out from the greatest common factor. But this one you can factor out, right? Because you have quadratics for x and y, and then xy is in the middle. So we can factor it out further. We have x minus y squared. And then the third one, we have x squared plus 3xy plus 2y squared. In this case, you want to factor out y. Do you want to factor out x? So let's start with 2y and y. And then you want to see which y you have to add. Yeah, you can just factor out plus x. Yeah, and then your LCM. So this is your first LCM. Your second LCM is just going to be 10 and 15. You need to factor that out as well. 2 times 5, and then 3 times 5. And so you're going to multiply 2 times 3 times 5. That is going to be 30. So your constant LCM would be 30. And then your factor for your polynomials would be x plus y times x plus 2y. I changed the orders, and then x minus y squared. Okay. Yeah, it looks very complicated, but if you remember all the rules for factoring, you'll be able to factor the polynomials and figure out the LCM. So this is very important when you're adding and subtracting rational expressions, because obviously you have polynomials and you need to factor out to match the denominator, right? So that was example 2, and try 2.